Guys, today we are going to look at graphical representations of domain and range. And so you're going to record these notes. Hopefully you've already checked your homework. If you haven't, I would do that first. Make sure you're good with just looking at sets of data. Now we're going to take a look at what that looks like graphically. And then we're going to kind of combine them all as we look at function notation later on next week. So what I would recommend doing is just pausing the video and drawing these three representations of data first. That way when we're going through the notes, it can go a little bit more quickly. Notice that I did loosely label these axes. That will be important. So make sure that you have a point at 1, 1 and a point at 1, 4, a point at 2, 3, a point at 3, 1, and a point at 4, 3 for that first graph. We'll talk about what this next graph means, but make sure you have most of the characteristics there for that graph. And then, those open circles are really important for example 3. So again, I would pause your video, sketch these 3 graphs, and then unpause. All right, so for example 1, if this were a function, we'd call it a discrete function. So this is a discrete graph, and we'll talk about whether or not it is a function or not in a minute. The reason it's discrete is because each of the ordered pairs is like a unique ordered pair. They're not connected in any fashion. It almost looks like a scatter plot. So we call this a discrete graph. So what we're going to do, and we did this last class, so this is very much building off of what we've seen before, is we're just going to state the domain and the range to start off. So the domain for this graph, remember what we did last class, and I'm going to go ahead and create 2 things for myself using the highlighter. I'm going to create we'll go with blue, a horizontal line, and that's actually going to help me find my ranges, and I'm going to create a vertical line. If I were in class with you today, what I would normally use is my pencil. So when I'm going to find the domain, what I do is I hold my pencil vertically so that it is perpendicular to the x-axis. So that's this green one. And what this is going to allow me to do is move along my x-axis and identify where I have x values that have an output. So notice that at 1, I have 2 outputs. So I have 1. Now I'm going to keep on moving my pencil. And then I see that at 2, I have an output. So I'm going to put a 2. I keep on moving my pencil. At 3, I have an output. And at 4, there's a value as well. So we have x values at 1, 2, 3, and 4. All right, now I'm going to move away from this vertical line, and I'm going to take my pencil and I'm going to hold it horizontally or perpendicular to the y-axis, and that's going to help me understand what outputs I have. So notice that I have for my range 1. There isn't an ordered pair at 2, so I have no input and output relationship for that. At 3, I have 2 ordered pairs, so I definitely have 3 within my range, and then at 4. All right, so our next question is this a function? And so based off of what we did last class, I think most of you know that this is not a function. And I'm going to give you another way to be able to represent or to be able to figure this out, because it won't always be as easy as looking to see kind of where that x repeats. So we have something called the vertical line test. And the way the vertical line test works is we take a vertical line just like we did before. So I take my pencil and I move it along the x-axis just like we did before. And if any vertical line, just like this one, hits 2 points, it means that we have an input that's trying to map to two different outputs, which means that this cannot be a function. So again, if I take my vertical line and at any point I have a singular input, in this case 1, that's trying to map to two different outputs, which means this vertical line goes through more than 1 point at a given input, then the graph is not a function. So in this case, because of 1 trying to map to both 1 and 4, this is not a function. So our vertical line test simply says that if a vertical line passes through more than one output for a given input, then the graph is not a function. All right, and again, so this one's not a function because it passes through 2 points. We have two outputs for one given input. All right, let's go ahead and move our pencil or our vertical line over to the other side. Again, this was an example of something we saw last class as well when we made that graph all together. So we were able to pull the domain, the range, identify that it's not a function. We now have this vertical line test, which is really, really helpful when I have things graphed to be able to figure out if they're a function or not a function. And so we have that vertical line test defined for us. Again, you can always pause the video if you need to finish kind of copying down notes. All right, example 2. In example 2, we now have what we call a continuous function. This is a continuous function. As you get into higher level mathematics, so I'm talking like pre-calculus and calculus, you'll get a better definition for a continuous function. But as it reads right now, a function is continuous if I can put my pencil at one point of it and I can trace it all the way along the curve without ever having to pick up my pencil, and I can go all the way to the other end. So every function that we're going to deal with this year, our linears, those were all continuous functions. We're going to move into exponential. Those are going to be linear functions. Quadratics are going to be are going to be continuous functions. So our linear, our exponential, and our quadratic, all of those, and absolute value, are all going to be continuous functions. In Algebra 2, you'll start to see some functions that are not continuous functions. They'll have some discontinuities. But for now, we're very much going to live in this world, except for this unit, where we're going to explore those domains and ranges of functions that may not be continuous. And so for this continuous function, we're trying to figure out a couple of things. We're trying to figure out what our domain and our range are. And we're also trying to figure out, well, we already just figured out, but it will kind of reinforce, is this a function or is this not a function? So to start off with our domain, I'm going to go ahead and take this green little vertical line and I'm going to travel it along. And so as I'm traveling along, notice that every single x value is represented, right? Like I'm just moving right along. There is an output for every single input on this curve. And this line right here that's going to continue to go up is going to continue to go up and up forever. And so even though I don't visibly see that every single input has an output, every single input on this curve has an output, because I could input any value into this function and I'm going to be able to get something out, which is really nice. So my domain for this function is all real numbers. And if you'll remember from inequalities, the way we wrote that was negative infinity to infinity. And so we tend to use interval notation for this because it's an easy way to kind of visualize what my domain is, because I could right now say like this graph is going to pass through at 0 and then it's going to keep on going. At 0.5 I have an output, at 1 I have an output, at 1.01 I have an output. So I can't pinpoint singular values like I could with the discrete function. I need to have a way to represent that it could be any number along my x-axis, and we use that interval notation to help us represent that. Our range is a little bit different, right? Because down here it's like nothing land, and this function is going to kind of continue in the direction that those arrows are going, and so there's no way for it to bounce back down here because there's nothing in this graph that tells me that this is all of a sudden going to turn around. And so notice I don't have any values below -1. But then at -1, I have a value, a couple different values, right? A couple different ordered pairs for everything from -1 to positive infinity. So we're going to say that we're going to include -1 as our output, and then we're going to go all the way to positive infinity. And again, I found that out by using my pencil. I'm holding it in a horizontal fashion because I'm trying to read the values that are on my y-axis. And I see that the smallest possible number is -1. And then from there, I'm moving up to positive infinity. All right, and now we talked about this a little bit already. This is a continuous function. So it's a function. There, for every input, there's exactly one out. For every input, there is a unique output. It passes the vertical line test. So notice if I have this vertical line, even though it looks steep kind of where those arrows are, it is going to just have one singular output for every input. And so that passes our vertical line test, and so this is a function. All right, our last example is a discontinuous, I'm going to call it a curve, because we don't know yet if it's a function or not. It could be a function. We need to see if it passes our vertical line test. And I just want to remind you that when we were doing inequalities, we had a closed circle and we had an open circle. And a closed circle meant that our function, or when we were dealing with inequalities, our closed circle meant that we included that value. And our open circle meant that we included every number up until that value, but we didn't include that exact value. And so we're going to see the same thing in our XY coordinate plane as we saw just along our x-axis when we were graphing those linear inequalities. And so as we take a look at this curve right here, it looks a lot different than what we've had before. But we can still identify what our domain and our range are. So I'm going to go ahead and grab my two little tools that I have up here and bring them down. And again, you're just using your pencil, and I would have just used my pencil in class had I not been out. So we're going to start with our domain. So I'm starting with a vertical line because when I'm looking at domain, I'm going perpendicular so that I can literally read what x values are true for this function. And I notice that this graph starts at -1, but there's an open circle. So just as a reminder from our previous unit, that open circle means that we use a parenthesis. So I have a -1, comma, and now I'm going to cruise along. Notice that I have an output I have an input, or output, I have an output for every single input. I'm good, I'm moving until I get to 2, and then I have something kind of funky at 2, right? I have an open circle and a closed circle. All right, well, this is a really unique situation. I have an open circle at 2, but then I have something else that's filling in that hole, right? I have that value at 2, 3. So I do have an output for 2. So I'm still good. I can keep on cruising. I have an output for 2, and it goes all the way to 4, including 4. So I'm going to go all the way until 4. And I'm going to include 4 because I have a closed circle. And again, the unique situation that I have here is right here. But that's okay because I don't have the point 2, 2. So there is no output at 2, 2 because I have an open circle. But at 2, 3, I'm filling in that whole ascent. Well, not filling it in, but I have a representation. I have an output at 2, and so I'm good to go. I can kind of keep on cruising. All right, now let's go ahead and check for our range. So now I'm going to use a horizontal line because I need something to read my y values. And so notice there's nothing before 0 because this is where y equals 0. And at y equals 0, we're starting things off. All right, we have an output, we're good, we've got a value. Notice right here, even though I have a hole right here, I have an output right there. So at 1, right, even though there's this one doesn't exist, I still have an output. So there is still part of this function that's represented, and so I do still have an output at 1, so I'm good there. I travel along. I actually have 2 representations, right? Right here and right there, so I'm good. I go up to 2. I've got another funky thing going on, but we're okay because even though it doesn't exist there, it does exist there, so I'm good. I'm going to keep on cruising all the way up until 1, 2, 3. So I'm going from 0 to 3, and I'm good. I can stop at 3 because there's nothing there after it. All right, now we need to determine if this is a function. So I need for every input to have exactly 1 output, right? So it has to pass that vertical line test. So I'm good, I'm cruising. I get right here. Again, this open circle means that there isn't really a value there. So I'm still good because I still have 1 output for my input of 2. So I'm still good. I cruise all along, so this is a function. It passed my vertical line test. And this is where that vertical line test really helps because it's not as easy because you don't have all those discrete ordered pairs. So a couple of things you may want to include in the notes to your future self. Just as a reminder that our open circle means that it's not included. And that means that we're generally using a parenthesis if it's like the beginning of a data set. Our closed circle, or the end, means that it is included. And so we're using a bracket. Another thing that you may or may not have noticed is that whenever I was looking for my domain, I moved from left to right and I moved up. I moved from down up. So when determining domain, we move from left to right. And when determining range, we move from the bottom of the graph to the top. To kind of summarize, we're always moving from negative to positive. So no matter where we're going, we're moving from the, I'll just say it, we're moving from the negative region all the way to the positive, or from negative infinity all the way to positive infinity. And we did that exact same thing when we were graphing inequalities and learning about interval notation the first time. All right, so from here, I have a delta math that should help to kind of make things make a little bit more sense, just because you'll be able to visualize it and see it a little bit more. And then you have a worksheet that looks like this for your homework. And so with these, you're doing your domain and your range again. And again, use your pencil and really kind of travel along to see what's going on, to see what that domain and what that range are going to be. If we have arrows pointing, then your domain or your range or both could be negative infinity to infinity, and that's totally awesome and cool. So give these a try. I am going to have the solutions posted so that you can check your work for a few of them. So I'm not going to post the solutions to all of them, but I am going to have in your Google Classroom, you'll see the solutions to some of these so that you can check and make sure that you're on the right track. All right, I will see you all on, what's today, day 3? I'll see you guys all on Monday.